Hi, Tom Altman here, getting ready to do some work problems in physics. This is for New York State Regents level or introductory college level. Question 1 says, how much work is needed for a person to push a box with a force of 14 newtons through a distance of 17.3 meters? Well, this is easy. They tell you the force, 14 newtons. They tell you the distance, 17.3 meters. And they ask for work. You know that work is equal to force times distance. Plug in your numbers and your units, and you get a correct answer. Units of joules, newtons times meters, newton meters, or joules. Question 2, what is the work expended when a mass of 6 kilograms accelerates at a rate of 2.45 meters per second squared through a distance of 19 meters? And they're looking for work. Well, work is equal to force times distance. We have distance, but we don't have force. So we need to find force. Force is equal to, well, mass times acceleration. We have that, so we can combine ma for F and write the equation. Work is equal to ma times d. Or work makes me mad. Plug in 6 kilograms. 2.45 meters per second squared. That gives you a number, and the units would be newtons. And then multiply by 19 meters. Newton meters would give you work units of joules. All right, question 3. A total of 240 joules of work. 40 joules. Needed to lift a 19 kilogram mass. So the mass of this thing is 19 kilograms. And you're lifting it in the air, which means you're going against the pull of gravity. How high was it lifted? What's the distance in the y-axis? What's the height? Well, the formula for work is force times distance. They give us the work. We're looking for distance, so let's divide both sides by force, and that gives us distance. So work divided by force. So we know what the work is. What's the force that we have to lift? Well, we've got to fight gravity, and the force of gravity, a common word for the force of gravity is weight, and that's mg. So we could write this equation as the distance in the air is equal to the work divided by the weight of the object. I covered question 4 in school, but for those of you that are watching this that don't attend my class, and for those of you that want to see it again, we've got a scooter with a combined mass of 120 kilograms. Used to do this lab, run the scooter up and down the halls. It was a hoot. They put in some new doors, so they slowed us down. So the mass is equal to 120 kilograms. It's at rest. That's important. That means my velocity initial is 0. It's accelerating through a distance of 15 meters in a time of 4.5 seconds. How much work is required? Well, work is equal to force times distance. Distance we know, force we don't know. Force is equal to mass times acceleration. These are all coming from the formula sheet. Mass I know, acceleration I don't know. So I need a formula for acceleration. When I look at my formula sheet, I find this one. Distance equals VIT plus 1/2 AT squared. Just spent 2 months talking about acceleration, so I can find it. So I do my algebra, velocity initial is 0, so I get rid of it. Distance is 1/2 AT squared, get rid of the 1/2 by multiplying both sides by 2. Now I've got AT squared, I want A by itself, so I divide both sides by T squared. I got A is equal to 2D over T squared. Alright, that works. So now let's substitute that back in. Force is equal to mass times 2D over T squared. And I substitute that in the work equation, and I can write work is equal to distance times mass times 2d over t squared. If my math skills are good enough, I can just combine these, and I can say that the work is equal to mass times 2d squared divided by t squared. Finally, how much work is required to launch a pumpkin with a mass of 3 kilograms straight up into the air? So again, we're fighting the acceleration due to gravity. and an altitude distance of 130 meters. And again, this is just work is equal to force times distance, and the force happens to be the weight, or mg. So this is straightforward as well. Well, hopefully that helps.